Take me to the frontier of particle physics today.
There's tremendous progress being made. It's such an exciting time in fundamental physics. Not only particle physics, but we said gravitational astronomy, the exploration of the force of gravity, black holes, quantum information, quantum computing, and all sorts of all that stuff is to me utterly fascinating. I think for the first time, it's probably true to say in particle physics, we don't know if there's anything else just around the corner, which is bad, but it's also, it is our duty to find things out about nature.
This is Star Talk. Niel Degrasse Tyson, you're a personal astrophysicist, and today we are featuring my exclusive one-on-one interview with my friend and colleague from across the pond, Brian Cox. Brian, welcome.
Oh, it's great to be back.
Oh my gosh. Oh, it's been too long.
Yeah, and we don't usually get to do it in person. It's usually over Zoom or something.
Right. Let's get some of your biography out there for stateside people who might not fully know who you are. You cut your teeth as a particle physicist. Is that correct?
Yeah, initially. I mean, actually, my degree is at the University of Manchester, by the way, in the UK. I've never left. So I started there doing my undergraduate degree, postgraduate.
What do they call you there now? You are professor of particle physics at the University of Manchester.
Yeah.
And Royal Society, as in the Royal Society of London?
Yeah.
Royal Society professor of public engagement in science.
Yeah.
So we're kindred souls across the Atlantic.
Yeah.
So, okay. So you never left. Is that because they wanted you so badly or that no one else wanted you?
Yeah, probably the latter. But I started, it was actually physics with astrophysics, my degree. So I did a degree in physics with astrophysics. Then PhD in particle physics, although the first year I was working on supernova neutrinos. So I was crossing over astroparticle physics, as we would call it. Then I got into particle physics, went to the DAISY laboratory in Hamburg and worked on electron-proton collisions, so-called diffractive scattering.
I've seen DAISY online. I've seen DAISY simulations of things. They simulate like colliding black holes and things. Fascinating. DAISY.
DESY, the Deutsche Elektronensynchrotron.
Yeah, but they have a public-facing platform.
See, I didn't know that.
Yes,
I didn't know.
Yeah.
Because the accelerator is no longer operational there.
Okay.
So but it's a huge lab in Hamburg.
Mm-hmm.
So I did my PhD there. That's in particle physics. Then moved to Fermilab in Chicago for a while. And then to CERN when we were building a Large Hadron Collider. And then, but I've always...
CERN, Switzerland, yes.
In Geneva.
And remind me, that's the European Center for Nuclear...
Research.
Yeah. Acronym, French acronymed.
Yeah, because it was founded in the 1950s. And at the time, so it was what part of the reconstruction of Europe really after the war. So it was that lab was founded, I think it was 1954, 1953.
Mm-hmm.
And so it was nuclear physics at the time. There wasn't really such a thing as particle physics, I suppose, at the time.
Mm-hmm.
And now it's by far the world's largest accelerator, particle physics lab.
Yeah, so, I mean, the center of mass of that whole world left the United States when we stopped funding our super collider.
The SSC in Texas, yeah. The SSC, Superconducting
Super Collider.
Yeah.
Yeah. I would have called it the Super Duper Collider. That might have kept its funding at that point. But so Europe still leads the world in nuclear particle research.
It's a very international lab. I mean, it is the world's collider.
Mm-hmm.
So although it's based in Switzerland and France, I would say it's a world lab.
Okay, that's very diplomatic of you.
Well, it certainly is. I mean, the US have a tremendous presence there, for example.
While you're saying all this to me, you're not describing this branch of your life as a musician. So just briefly remind me of that.
Yeah, so when I was 18, traditionally you would go to university there, start a physics degree. But I didn't, because I was in a rock band that I joined just before
I'm sure your parents loved that fact.
They did actually. They loved it.
I could go to college and major in physics or continue with my band.
Oh, but do you have that thing like a gap year, we call it, where you say, well, I'm going to take a year off the studies before I go to college or university? And so I'd said that. I'd said, I'm going to be in this band and I'm just going to do it for a year and then I'll go and do physics. But then we got a record deal. A big record deal with A&M Records. This is in 1986, 1987. It's a long time ago. Got a big record deal. And so we I came to Los Angeles and recorded an album with actually produced by Larry Klein, who was married to Joni Mitchell at the time. And so we recorded some of it in Joni Mitchell's studio in Los Angeles. So, and then we toured with my first professional gig with that band was with Jimmy Page, supporting Jimmy Page. And
did you open for Jimmy Page?
Yeah, we opened for Jimmy Page and Gary Moore, who'd also been in the band, Thin Lizzy, and then Europe, the Final Countdown. So you know this song, The Final Countdown, and Carrie was a big hit here in the US. So we opened for them, made a couple of albums. So I did that basically for 5 years.
And it charted?
Actually, no, we did big shows. It was a rock and roll band. And then I left that band, went straight back to Manchester and went to start a physics degree.
As one would do, yes.
But then in that little gap, I joined another band who then had some hit records. So a band called D-Ream. This is in the early 90s now. And they didn't have a record deal when I joined them, and they got a record deal as well. So when I was at university, I was in this band. We had a #1 hit in the UK and Australia with a song which violates the second law of thermodynamics, which you'll love, called Things Can Only Get Better, which is clearly incorrect. Certainly,
things can only get worse. Globally in the universe. Yes.
Exactly. So I had a two.
Wait, and that song, what helped it, if I remember correctly, some political candidate adopted it as their theme song.
It was Tony Blair. It was
Tony Blair.
Yeah, it was Tony Blair in 1997.
It became his associated with his election.
Yeah, and came back actually into fashion because we just had a change of administration in the UK. And that song came up again, and it came up and it got quite popular again. So I did Glastonbury this year with the band.
Wait, that's that huge place.
Yeah, the big festival, yeah.
That's any huge scene of musicians in the UK is at that location.
Well, it's probably the biggest festival in the world, I would imagine, I would guess. So it's a huge festival.
So you and Brian May.
We are the two. He did it the other way around, though. He got extremely he got extremely famous and then finished his PhD
in astrophysics. Yeah. Okay. Brian May, lead guitarist of Queen. Yes. Yeah. So let's pick up some of the physics. We are both here right now in Las Vegas at a World Skeptics Conference. Yeah. We're both skeptics. I mean, any scientist is a skeptic, but the problem is when the world does weird things, who's going to put them in check? Somebody's got to show up at the scene and say, no, that's not how that works. Or no, the laws of physics prevent that. Or you've had to do this in the UK, right? There's certain resonances between the United States and the UK about how people misthink things. So what was your baptism into this world?
Well, actually, I mean, I was only interested in doing research for a long time. So as a postdoc and in that part of my career, I didn't want to know about anything else other than doing research. And that's all I did. But it was, I can't remember when it was now, but there was one of those regular funding crises, as you'll know from here in the US, when government support in particular for research dipped. And so I got involved in trying to fight that. And we realized, I mean, it's kind of obvious, I suppose, but we realized that one of the reasons, talking to government, that they had cut the research budget was that they didn't think anyone cared. So they thought it was a simple thing to
democracy.
Do. You could just, and so we all, as a community, we were we learned again. We've learned it over the years, but we learned again that popular support for what we do is important. And where does the support come from? It comes from understanding. And there are many reasons, by the way, why talking to people who are not in science about what we are doing as scientists is important. One of them, of course, is just purely democratizing knowledge. We taxpayers fund, at least in part, what we do, and therefore they have a right to know. So there's that level. But on the other level, which I think you're suggesting as well, what science does, I think it's not about knowing the facts. Like it's not about knowing the universe is 13.8 billion years old, for example, or it's 13.8 billion years since the Big Bang. We could talk about that later, actually. Does that mean it had a finite origin in time in the past? Anyway, But it's not
put a pin in that. We'll get back to that, okay?
It's not about knowing facts so much as understanding something about the process by which we acquire reliable knowledge about the world. And science is the process by which we acquire reliable knowledge. And so I think that
it may be unique
realized
in that. That.
Well, in the sense, I think in a sense that nature is there, whether the job of the scientist is to find out how it works. And it, of course, as Richard Feynman and many others have famously said, it doesn't care who you are or what your opinion is or how popular you are or how many votes you got or anything, how much money you've got. It just doesn't care. So in that sense, I think it is a unique pursuit because the standard by which your opinion is judged is external to us. It's nothing to do with humanity.
Nature is the ultimate judge, jury, and executioner.
Yeah. So I think I became involved initially just on that very narrow idea that we wanted to make sure that people understood what we did and what the value of it is. And then that branched, that became bigger and bigger in my career and branched into television and live shows and all sorts of things. But it came from that. I wasn't interested in communicating science. I was just interested in doing it for a very long time.
So you had a certain duty and responsibility to the world.
Well, I think we all do. I mean, I've realized since that I think actually Feynman again said it's a very brilliant essay that anyone can download from 1955, I think it is, called The Value of Science. It's just 4 pages and it's on Caltech's archive, I think. And in there, he says that it is our duty as scientists, our duty, knowing the great value of, he defines science as a satisfactory philosophy of ignorance, which is a beautiful, just merely satisfactory, it's a philosophy of ignorance. You start out from not knowing. And he said the great value of the satisfactory philosophy of ignorance, the great value of freedom of thought, to proclaim that freedom and to try to protect it for all coming generations, he essentially says at the end. So, but I like the framing. It is our duty as scientists to do that, as well as do our job, which is to find things out about nature,
about the natural world. And in this conference, I am to bestow upon you the Richard Dawkins Award for Science and Reason. Bestow, yes. The Richard Dawkins Award is something I won last year, and I was called back in to bestow it upon you.
It's passing a torch. It's a great honor.
It will be a delight for me. It takes place tonight.
Yeah.
I look forward to that. And just the idea that science and reason is something, maybe it's sad that it's something that needs to be rewarded because if it's one of these awards that if the world functioned just right, you wouldn't need it.
And also, although I said, as Feynman has said, it's in a sense our duty as scientists. It is also true that not all scientists want to do that or feel comfortable with it. As I said, I didn't want to do it initially. Now I very much enjoy it and think it's very important. But so we don't need everybody to do it, but some people will. And that's important.
Right.
Discussing big ideas with experts from physicists and biologists to entertainers and politicians is our favourite way to critically explore the world around us. And now, with SpaceX's Starship on track to ramp up its launches, Elon Musk is turning visionary ideas into real progress. However, since his cabinet appointment in Trump's administration, many are wondering about Musk's conflicts of interest, his influence on policies, and more. So tracking developments through reliable sources these next 4 years is absolutely essential, something our long-term partners at Ground News simplify. They're an app and website founded by a former NASA engineer who brought the same level of precision she needed up in space to how we consume information here on Earth. Access every perspective shaping a story with data on how credible their reporting actually is. Or burst your media bubble and find important angles impacting space and beyond you might have otherwise missed. With science increasingly becoming a political talking point these days, access to a platform designed to bring clarity to even the most polarizing topics has never been more important. So head to ground.news/StarTalk or scan the QR code to subscribe to Ground News today. we're giving our viewers 40% off their top-tier Vantage plan, knocking the price down to $5 a month. The decisions made in the coming years could profoundly shape the future of space exploration and more, so we really can't recommend enough finding clarity through ground news. Now, let's get back to the show.
So let's talk physics. Take me to the frontier of particle physics today. What's going on at CERN now that the Higgs boson is discovered and the Nobel Prizes were granted? What are they doing now?
Well,
did they just close shop and go home?
No. I mean, what particle physics is, because we're talking about quantum mechanics, basically, it's statistical in the sense that you collide, what we do there is collide protons together at high energy. And we collide a lot of protons together at high energy.
Protons have a charge so that you can put them in a magnetic field and accelerate them to very high speeds.
Yeah, so they go around. So the LHC in kilometers is 27 kilometers, and that's the number I was
circumference.
Yes, that's about 16 miles or something like that.
Mm-hmm.
And the protons go around that ring 11,000 times a second. So that's how fast they go.
That's fast.
So that's 99.999999% the speed of light.
Okay, so you've granted them energy so that when you collide them, you break them apart. You're basically deconstructing nature to see what residue comes out of it. When I think of doing that for anything else, it's going to break, right? I don't take chairs and slam them together and still have chairs. I have a pile of kindling, okay? So who ever thought it was a good idea to smash nature into itself?
Well, I suppose Ernest Rutherford initially. So we go back to Manchester, the turn of the 20th century, and Rutherford was using radioactive